Greetings, everyone, and welcome to the Pan Future Society podcast. I am your host, Sean, and today is Saturday, July 1st, 2017. Education matters, and facts matter. And it's a difficult thing we've been dealing with in the United States lately. But also, let's not forget other places in the world where facts are being assaulted. Russia is given more power for Vladimir Putin to select the president of the Russian Science Federation, RAS. I forget what that stands for. And in Turkey, evolution is no longer being taught in school. So, that's not good news. I don't know who's doing it right, but it's not us, and it's not the Russians, and it's not the Turks. Maybe the Chinese. I don't know. Anyway, sort of start the show on kind of a bummer note. So, let's get on with the news of the moment. A study from the University of Michigan Medical School and Harvard University has shown that an artificial intelligence program can help doctors diagnose brain tumors more quickly and potentially accurately. A team of physicians and scientists used a deep learning algorithm to analyze 100 different brain tissue samples and accurately classify most of them into several broad categories. Using a tissue collecting and sampling study method dubbed stimulated Raman histology. Normally during a brain surgery, surgeons must pause the procedure for 30 to 40 minutes, allowing for time to process, freeze, and stain the brain tissue in a lab. But using this deep learning algorithm, they were able to reduce that time to just 3 or 4 minutes. This is a massive drop in that time, which means a much reduced risk for complication during the surgery. You don't have to just stop the procedure with someone's head open and wait for the results. The accuracy has been around 90%, which is slightly less than the traditional methods of 90 to 95%, but certainly as the algorithm learns, it should become more accurate. And anything like this that can save that much time during such a complicated surgery is pretty remarkable. And now?
It came from outer space.
Snakes on Mars. Well, no, not real snakes, but potentially robot snakes. We have sent a number of rovers to Mars, but they all have wheels, and that can have its drawbacks. Spirit got stuck in the sand, and that was the end of its mission, and there are just places that the others can't get to. However, a group in Scandinavia at the Foundation for Scientific and Industrial Research has proposed designs for robots that use the snake-like method of getting around. And this is one example of researchers using the idea of biomimicry to solve a problem. Biomimicry, in other words, looking at the way other animals get around to see if that can be adapted for robots. We know how to make wheels and we know how to walk, but that doesn't mean that robots have to have wheels or walk. They could certainly get around other ways. And in certain situations, that might be much more helpful. This design was originally made for the ISS to perhaps have a robot assistant on the space station that can get into spaces that are difficult for the astronauts to service. However, this could also be adapted for Mars. Possibly it could be toted around by a rolling rover and sent off to crawl underground in a space that the rover can't get to. or something such as that, or climb up some rocks to a higher point. Many uses that this could potentially have, given that it uses a different method of locomotion to get around and could have an easier time in places where our wheeled rovers cannot go. And that's the news of the moment. In the main segment this week, I'm going to cover some methods of energy generation that are less well known and perhaps less effective, but might be very useful depending on the use, the needs, and the location. I also have a few thoughts on the grid, storage, and efficiency issues. One somewhat well-known but lesser used method of energy production is geothermal. It's used both to generate electricity and to directly heat water, power industrial processes, and for space heating. Well, there is enough heat in the Earth to power the entire planet several times over. In most places, it's difficult and expensive to get to. It also has less efficiency than other methods, usually around 10 to 23%, as the heat dissipates rapidly as it's drawn from underground. It's easiest to access in areas near tectonic boundaries. There is also a problem of gases like carbon dioxide, methane, hydrogen sulfide, and chemicals like mercury and arsenic that are brought up using this process. Plants typically have control systems to avoid releasing these into the environment, but like any plant, accidents happen. In some cases, land subsidence and uplift have occurred, not unlike problems associated with fracking. Iceland is well known for its use of geothermal energy, but it is used all over the world. And as various costs come down and technologies improve the efficiency and pollution capture, I think geothermal will become a more widespread option in certain regions. Biomass and biofuel are both considered in the mix for energy production, whether for heat, automotive fuel, or other use. Biofuel would be something like using algae to chew through some process to make a biodiesel fuel. Biomass is essentially burning anything from wood to waste from farms like corn stalks. And the thought there being that you would plant more corn and sequester the carbon. Sometimes it can be processed into blocks, but really just burning any kind of plant material is under the biomass umbrella. The general assumption is that growing new plants or algae for production of fuel will draw enough carbon out of the air to be carbon neutral. However, you still have to burn it. Particulates and gases are released, and climate change aside, air pollution is in general very harmful. The WHO estimated in 2012 there were 3.7 million premature deaths due to air pollution. There's also the issue of arable land. We are using all of our good arable land already for food production. In Brazil, people have cut down massive swaths of the rainforest to grow oil seeds. This does not seem like a good trade-off. There is research in engineering plants to produce more oil, thus use less land, and there's also a Spanish group, Ecofasa, working on making biofuel from trash. Urban waste is treated with bacteria to produce fatty acids, which are then used to make fuel. Even with more recycling-minded system, I question the value of burning any fuel. On a smaller scale, maybe we can use the good old flywheel. A very old mechanical device with many uses even today. It's not that different from winding a mechanical clock or watch. Simply put, a flywheel is a mechanical device for storing rotational energy. However, there are modern designs that go far beyond winding up a clock. Using magnets, low-friction materials, and other modern innovations, flywheel electrical systems have been built that can offer a few kilowatts of power. They are highly efficient, up to 80%, but tough to build for large-scale use. It's probably not something you'll ever power a city on, but maybe as a backup home power system or as a supplement to other energy sources like your solar and wind. You can even buy them right now for your home. Some are very small, maybe suited to provide some electric light in developing regions, so they burn less wood or propane and kerosene. Some systems are sold for use with off-the-grid type homes, providing backup power and some energy storage for overnight use. They do, of course, need to be wound up, either by hand or by using excess power drawn from other sources, like hopefully you will have enough solar power during the day to run your stuff and add extra to the flywheel storage. So the good old-fashioned flywheel might be an option for you. And what about energy from space? Can we bypass the atmosphere to get full sun exposure and get that energy down here? In general, designs for space-based solar power involve a large solar array in space and a large antenna on Earth. Power is beamed from the array to the antenna via laser or microwave. There are designs from NASA and others that would place solar panels in space and relay it to the ground, and these have been worked on since the early 1970s. As of today, Russia, China, and Japan are more actively pursuing the technology. The U.S. discontinued its projects over various concerns in the 1980s. A version was revived in 1999. The concerns remain, though, largely with the massive cost of a space-based array and the needed antenna on the ground. Land use issues were also a main reason that more hasn't been done with this. You'd need a large spot of land for that antenna on the ground. And also the lack of ability to maintain the panel in orbit as easily as ground-based panels. But perhaps with robotic systems, this technology will be more viable in the near future. I think I would also like to see the continued development of very large panel arrays for space station use. Even if the energy isn't beamed to the ground, someday a space station housing 10,000 people will need a lot of energy. For those who look to renewables to entirely supply our needs, even if you just think of supplementing needs with solar panels on your roof, there are some other considerations. Storage is the big brass ring right now. What do you do when the sun isn't shining or the wind isn't blowing? Home battery storage is just getting started, but it still has a long way to go. And on a large scale, there isn't really anything out there. There are a few projects, like one in Australia at a huge solar farm. It will use 1.1 million batteries, and that storage capacity can provide 100 megawatts for an hour when charged. That's not base load power. That might be good for occasional peaks or blackouts, but that is not a system that will run overnight through the dark. Oh, and it will also cost $1 billion. Storage will get there, but we need something now. And we also need to consider the grid. In the United States, it is in many states old, sometimes unreliable, and a confused mess. Do we invest the money and somehow wrangle the cooperation to have a solid national grid, or do we have more localized power production? Can we change the convoluted way that energy markets work? Should we have small neighborhood solar, wind, nuclear, hydro systems appropriate for the locations they are in, and forego the large plants that we have at the edge of town now? If you want large plants, then we need to develop better ways to get energy from the wind farms in Iowa down to Florida, or from some solar farm in New Mexico up to North Dakota. And I think we can do more with our usage. Our appliances are more efficient, but research should continue to make them better. And it would help if we could reduce our consumer culture. Sure, we all know LED lights are massively more efficient than incandescence and fluorescence, but we also now have more lights than ever. They are small, they are getting ever cheaper, and they can be used in many ways incandescence and fluorescent lights can't. So our use is increasing. We have lights on everything. We may erase any efficiency benefit simply by having LEDs everywhere in our lives. That's just one example of the way we have more electronic stuff everywhere. Your refrigerator might be more efficient than it used to be, but if you've added an Amazon Alexa device, there's another thing drawing power from the grid. So how many things drawing power do we need? Can we reduce that number? Does it help? I would like to see more effort done in that area to bring those numbers to bear. Just some food for thought. Think about your own use of power on a day-to-day basis. This is my final energy-related show for now, but I'm sure more will come up in the future. I want to leave you now with the encouragement to think deeper about this issue. Consider what the science says about nuclear energy. Consider the drawbacks to any of the options discussed on this series of shows. There are trade-offs, and which ones will be better in the long run? All right, there's your show for the week. Thanks for sticking with me through these series of energy production episodes. On to something completely new next week. As always, you can come to the website panfuture.org to see the show notes, links to sources of information, videos, and whatnot that I collected for the episode. And send me a message. There's a contact page there. There's a donate button. Also, if you would like to help the show out with a non-monetary method, be sure to write reviews on iTunes or wherever you happen to get your show from. That is greatly helpful to promote and spread the news and all that. And in addition to spreading the news that way, share it with your friends if you got people who might be interested in this sort of thing and need a Training Wheels beginner intro to futuristic science things. Send them the show. You can send them the files, send them links. It doesn't really matter to me either way. Just anything to spread the word and get the news out there and make people think about the long term. All right. I guess that's all I got for you this week. I will talk to you again in the future.